Okay, today we're going to cover transformations. As you all know, there are 4 types of transformations out there. There are translations, rotations, reflections, and dilations. Today we're going to go through each one of those and talk about the differences and how to write them and how to do them. Okay, so translations, rotations, and reflections are the congruence transformations. They are also called isometric transformations because they only change position of the figure. They don't change the shape or the size of it. So the objects will remain congruent. That's for translations, rotations, and reflections. But when it comes to dilations, it's a little different because they are not a congruence transformation, they are similarity transformations because they result in 2 objects that are similar but not congruent. Okay? So basically, what they're telling you is translations, rotations, and reflections, the object never changes. It just moves. Does that make sense? So I could write object moves. But when it comes to dilations, the object changes by enlarging or reducing. Okay? And that R looks really funny. So do y'all understand what that is trying to tell you right there? Okay. Can I change the screen? We good? Alrighty, on to the next screen. First thing we want to talk about is a translation. A translation is also called a slide. A slide means it moves up, down, left, or right. Okay? Now, there is how you notate it. If you have a certain point, say X, Y here, if you translate it to the right, then you're going to add a number, A, to the X value. But the Y value does not change. Because if you're doing anything to X, that's going to be right or left. Okay? Right is plus, left is minus. Understand? Now, when you're doing something to the Y, it's either up or, what's the other one, guys? Down. Okay? If you're going up, you're going to add. If you're going down, you're going to subtract. Okay? Now, it's going to ask you on your assignment, given this point, write the translation in coordinate form. If you go right so many, or an up so many, or left so many and down so many, or a mixture of the two. So you need to understand, if you're going right, you add to X. If you're going left, you subtract from X. And that's how you would write it. If you're going up, you'd add to Y. Sorry. If you're going down, you'd subtract from B. Does that make sense on translations? So let's take a look at one. I'm going from triangle ABC to triangle A prime, B prime, C prime. Okay? They want us to write this in coordinate form, this translation. Do I have to look at every single point? It's a translation, right? If it's a translation, does the shape change? No. So I can just use one of my points, right? So let's use A. So I'm going to look at A, and I need to ask myself, did it go left or right to get to A prime? Left, right? So 1, 2, 3, 4, 5. So I went left 5. I'm just writing notes right now, okay? This is not the actual translation notation, okay? Then I ask myself, did I go up or down? Up. How many? 2, right? So when I write my coordinate notation, what did I do to x? I went left 5. What is the, how do you write that? Minus 5. And then I went up 2, so that would be y plus 2. That's how you would write it. Alright, so that's translations. Now let's talk about rotations. A rotation is simply when you turn the object. They're rotated around a certain center. For our how do I word this? For this particular class, we always rotate about the origin. Okay? Rotations are mostly counterclockwise, unless stated otherwise. So if they tell you to rotate something by 90 degrees, they want you to rotate counterclockwise. Okay? So I would write in my notes, it's always counterclockwise unless told differently. So you can remember this, okay? Always rotate counterclockwise unless it tells you to do clockwise. Now, some of you are going, okay, but how do I do that when I'm just given points? Well, that's what this box down here is all about, right here. If you start out with a point, original point, if it tells you to rotate 90 degrees, you're just going to switch your x and y and negative the y. If it's 180 degrees, you just negative both the x and y and nothing moves. It stays x comma y, is just now negative x comma negative y. Set 270 degrees. Mind you, all of these are for counterclockwise. Okay, but here's something funny. If you're told to do it clockwise, then you can go backwards from counterclockwise. So if I wanted to do my clockwise here, right? If I go clockwise 90 degrees, that's the same as going counterclockwise 270. Okay? 180 is still 180. That one didn't change. But if I'm going clockwise 270, it's the same as counterclockwise 90. And we all know 360 stays 360. It's a complete full circle all the way around. Okay? Do y'all understand that about the counterclockwise and the clockwise? Okay? I would add that on because they're going to try and trick you and tell you to do clockwise instead of counterclockwise. Ready to move on? Okay. So let's try some rotations. They give you, this is the original, the top one, and they want us to rotate clockwise 90 degrees. So that would be counterclockwise of how much? 270 degrees. So then we can go back and look. 270, we switch the numbers and negative the x value, right? Okay, so let's see how we would do that. Well, this one right here is negative 1, 1, right? So I would switch negative 1, 1, become 1, negative 1, but change that negative 1 to a positive, right? So that would be at 1, 1. Right? Okay. Then do the same thing. This one is at negative 3, 0. So they'd be at 0, 3, right? Well, there's not a 3 on here, so we guesstimate that it would be probably about right there, right? Then my next point is down here. That's negative 3, negative 3, right? So then it would turn into what? Negative 3, positive 3. Okay. And then last but not least, your final one is at negative 1, negative 4. So that would be at negative 4, positive 1, right? So then if I drew in my lines, same exact shape, just rotated 90 degrees clockwise. Are y'all catching how to do those rotations? That one at least. That one was a tricky one because it was clockwise. Okay, 180 degrees. All you do is negative the x and y values, right? So if this one's at negative 1, negative 1, it would then be at positive 1, positive 1. Okay. This one's at negative 1, positive 3. It'd be at positive 1, negative 3. Negative 3, 0 would go to 3, 0. And there it is. Those patterns I gave you really help, don't they? Now, rotation clockwise around the origin, 270 degrees. So if I look back at that chart, a clockwise rotation of 270 is the same as a counterclockwise of 90. So switch them and negative the y. Negative your y value and switch them, right? Okay, so 1, negative 1, 1. Wouldn't it stay the same? Negative 1, 1. Right? Okay. Negative 3, 0 would be 0, negative 3. Help me out, guys. Is that right? What did we do wrong? That doesn't look right. I think it's the, oh, it's negative 1, positive 1. Negative 1, positive 1 would become negative 1, negative 1. There we go. Bless you, bless you. Okay. Then this one, negative 3 would become positive 3, negative 3. And then negative 1, negative 4 would become positive 4, negative 1. You see how it's rotating? Rotation's pretty neat, right? Okay. So let's move on from rotations to Yay! Reflections. Reflections are flips. Now, there are 3 types of reflections. You've got over the y-axis. When you flip over the y-axis, you change the sign of the x's. Or the x values. Okay? Then you've got over the x-axis. And you change the sign of your y values. The last reflection you will have is over the y equals x. Okay? These are the 3 most common. And for that one, your x and y values switch. And I can't spell switch. Now, are there other type of reflections out there? Yes, they could have you flip over x equals 3 or over y equals 2. But most of the time, these are the 3 more common ones you're going to see. Okay? So let's try some reflections. You good? We good? Okay. So if you look on here, there's a red dotted line, right? What's that dotted line on? The x-axis, right? Which means I change my y values. Here's another way you can do it. See, I'm starting here at point D. Count 1, 2 to the x-axis, right? Well, then it would just go 1, 2 to the other side. Okay. So how far away is C? 1, 2, 3, 4. So I go 1, 2, 3, 4. And put my mark. That's another easy way to do it, right? Finally, A is 1, 2, 3. So 1, 2, 3. Put it there. And I'm missing B. B is 2, 2. Come in like that, up like that, down, and up. And I reflected it. Kind of neat. Do y'all understand reflections now? Okay. So what if I was doing it over the y-axis like this one shows? Instead of counting up and down, I'm going to count what? Side to side. F is 1 away, so I go 1 away in the other direction. E is 4 away, so if I go 1, 2, 3, 4 in the other direction, there's the new E. There. And then finally D is 1 away, so 1 away. And there's my new shape. The most tricky one is the last one, over y equals x. So I need to think, let's start with A here. A is at -5, -2. So now it would be at -2, -5, right? It's going to be down here. B is at -3, +1. So then 1, -3. C, 4, 3 would become 3, 4. And then D is 5, -3, so -3, 5. Connect them. And there it is over the y equals x. Okay, so y'all understand the concept of reflecting now? All right, so let's get into our last concept, dilating. Okay, how many of you have heard the word, we gotta dilate? What do you hear it mostly for? You're when you get your eyes checked, right? Okay. What they're doing is they're making your pupils get really big. Okay? So they can see inside of there and make sure your eyes are okay. Well, a dilation, that's an enlargement, right? They're getting bigger. But a dilation is not only an enlargement. You can also have a reduction, meaning it gets smaller. It's the same shape, different size. Okay? So, the big thing you hear in dilations is scale factor. If your scale factor is 1 or bigger, if it's 1 or larger, it's an enlargement. Or it's got to be larger than 1, sorry. If it's over 1, it's an enlargement. If it is between 0 and 1, in other words, it's a fraction, then you're reducing your size. Okay? To figure out a dilation, it's always new divided by old. That will get you your scale factor. Okay? When figuring out scale factor, it's new divided by old, always. Alright, so let's look at some stuff. So it says, dilate the triangle in the graph below by a scale factor of 2. Now, using point 0, 0 as center of dilation. Center of dilation will always be 0, 0 for this class. Okay? So, factor of 2. What does that mean? It's getting bigger, yes. How would you do that? It's really simple. You multiply every x and y value by the scale factor. So if a was 0, negative 2 is a, right? Your new a prime will be 0, negative 4. So if I'm looking at b, it's at 2, 2, right? B prime was going to be at 4, 4. C is at 3, negative 2. So C prime would be what, guys? 6, negative 4. And then if you connect your dots, you will see that it makes the same triangle, just a different shape. Okay, okay. I told y'all I can't draw a straight line on this thing. That's as close as you're going to get. Okay? Alright. There's one other thing I want to pre-warn you about and tell you how to do, and that's